Hey there, hi there, ho there. Good morning. This is Dawn Zoldi. I am your host for the Inner Drone Drones at Dawn weekly podcast, and we are knee deep into our safety and security month. So last week we had Luke Fox from White Fox Defense Technologies talking about security and counter UAS, and today we are so pleased to have with us John Damush from Iris Automation, who's going to talk about their amazing detect and avoid technologies and what they're doing at Iris Automation for safety and to take drones to the next level. So reminder, everybody, this is live. So please engage with us in the chat. Ask John your questions. Give us positive encouragement. We absolutely love that. So good morning, afternoon, evening, wherever you are in the world. And welcome, John.
Good morning, Don. Thanks for having me on.
Well, what a pleasure to have you, John. And if you wouldn't mind telling us a little bit about yourself and your background.
Yeah, sure. I'll try to keep it brief. Always been interested in aviation. Was one of those kids in the airport that drove everybody nuts talking about how much thrust every engine could produce on a 727 and how many passengers and what seating configurations. So that kind of drove just an interest and a passion in math and science. Got an undergrad in aerospace engineering. Been fortunate enough to have a series of roles in startups and large companies related to aerospace, ranging from flight simulation to computer vision for sensor payload processing, and now all the way to being chief executive of Iris and working on the mid-air collision avoidance problem.
Well, that's a big problem to work on, to be sure. And, you and I have talked before, John, about how we both, it's both of our passions to elevate the drone industry. And so could you tell us a little bit about how you plan to do that at Iris?
Yeah, so I kind of skipped over briefly. A couple stops in my career. One included a company called Insitu, which is Boeing's subsidiary that makes the ScanEagle and the integrator drones. These are large aircraft. I mean, the ScanEagle is anywhere from 50 pounds to 95 pounds, and the integrator is well north of 150 pounds. And they're super long endurance, gas powered drones. And when I came into the Insitu business, one of my jobs was to stand up the commercial business unit for Insitu. And as we went to do that, it became apparent that there needed to be more clarity around the integration of unpiloted systems and piloted systems in the national airspace. And there were a number of use cases that were already being done, largely by piloted aircraft. But they weren't actually the safest missions. These are 400-foot power line surveys with clipboard on the pilot's lap and a DSLR camera leaning out the window. So it's not exactly the way you'd want to do this job. And unpiloted systems present great promise for helping do those missions more safely, more efficiently, and frankly better, because the predictability and the repeatability of that mission is going to be better. So I really want to see world enjoy the benefits of unpiloted aircraft at all altitudes. And I get a question all the time, Don, why the sky's not dark with drones yet, considering that drones have been around now the better part of a decade, and there's tons of hype and momentum in the marketplace around small drones specifically. But why don't we see more of them? Well, part of that challenge is that there's two main factors that are kind of the big hurdles that have to be jumped. One is command and control when now you don't have a human on board, right? You need to have reliable, predictable, high quality of service command and control links so that you're always in command, you're always on the loop in some way. And then the other one is the aspect that we're focused on here at Iris, and that is detecting the non-cooperative threat so that you can avoid mid-air collisions. I like to define for our audience, although many of them are probably expert already, when I use words like non-cooperative, sometimes people imply that to mean that that's somebody doing something wrong. Well, no, actually not at all. There's plenty of people that are allowed to just go fly. God bless America. This is great. Like, we have this freedom of the skies, and they can go jump in their Cessna, their Piper Cub, their Mooney, whatever aircraft they want in the right airspace and not talk to anybody, not file a flight plan, not have a mode C transponder, not have ADS-B. And it's totally okay. But what that makes them for the drone operation that's trying to do an inspection, let's say, in that same airspace, is they're a target that we're not talking to. Therefore, we can't cooperate to avoid each other, hence non-cooperative target. So it's pretty clear that the drone business, the unpiloted community, has a bit more responsibility in terms of detecting and avoiding other aircraft, because it cannot be reasonably assumed that the pilot in the piloted aircraft is going to be able to see and avoid the drone, largely because of the size differential, the speed differential, the relative perspective of where the general aviation aircraft is flying and where the drone is flying. So we need to do something, and that's the problem we're focused on, is really trying to give the drone operators an ability to detect the other aircraft that are in the vicinity so that they can then choose or automatically avoid any potential collisions.
Yeah, John, you and I were on a panel together, webinar with AUVSI Cascade chapter,
That's right.
and with Tom Fury from SageTech. And for everybody out there, you might want to go back and check that one out too. I actually have it posted to my website, p3techconsulting.com, under webinars, I believe, or podcasts, I don't remember. But that was a great one to get kind of the full spectrum picture with SageTech and their transponders, and then John with the detect and avoid. And I did a little bit about the law and this idea that see and avoid is the linchpin of safety for the FAA and in the national airspace and globally, really, when you think about it. And, obviously with a pilot on board to see, and without a pilot on board, it becomes detect and avoid. So let's just jump into that then, John. Not everybody understands this concept of detect and avoid. Can you explain that a little bit for the audience?
Yeah, it goes back to the basis that I just mentioned a little bit, and you alluded to as you use the word see and avoid. Even that is based on the concept of see and be seen, where the two aviators would share the responsibility of seeing and avoiding each other, right? And there was an assumption that both were conspicuous enough to be seen. Well, with the small drone space, that assumption is basically not valid anymore. So how do you satisfy see and be seen so there can be a shared responsibility? And frankly, through that shared responsibility, you get the kind of redundancy that we're used to in aviation. Well, with the drones, the smaller aircraft, we immediately, guilty as charged as an engineer, jumped technology, right? Oh, there's got to be some sort of technology that we can put on board and we can make sure everybody can, see and be seen by everybody else. Well, that's great, except that you can't just unilaterally force every other aviator in the airspace to add new technology. There's significant challenges to doing that. There's cost challenges, there are integration challenges. There's a big percentage of people that just might not do it. And if that's the case, then actually you're eroding the installed base of the aviation industry. And we don't want to do that, right? We want to grow the installed base of aviation. We want to bring aviation to many, many more people who haven't enjoyed the benefits of flight, for whatever that is, whether that's personal travel, whether that's shipping parcels, whether that's operating their ranch, you name it. And this is where drones really have great promise, especially below the kind of 500-mile distance range, where frankly, I don't know if you know this, 95% of us drive for a trip less than 500 miles today. Some of that's due to the fact we just don't have an alternative like rail, like you might have in some parts of Europe or Far East Asia. But it's just that it's not economical yet to actually have air travel at those distances for the demand profile that you would see, which would be rather smaller plane loads, right? So you'd have these little niche airlines here and there, like Cape Air, the Wings TV show episode. I just dated myself. That was done with a Cessna 421 to, Nantucket and back and forth to Boston. So there's little niche markets where those airlines can make a living, but broadly, you don't see them everywhere else. So bringing this to market is really critical. Back to your question about the derivation of detect from see. Well, for you, someone who's familiar with the law, the regulations are law, and the word that's codified in law is see. So, okay, great. Like if I was in a court of law, how do I prove that I saw that target? And hence the word detect is probably more accurate, because you do want to deploy as many different sensing modalities as possible to be able to detect a potential collision. We tend to use a vision approach, largely because of the size, weight, and power advantages it gives us, but it also brings some disadvantages. And, we have to be able to see it, just like a human has to see. Fortunately for us, the rules are written in a way that it disclaims the operator from the collision avoidance task if instrument meteorological conditions are present, i.e. if you can't see out the window, then there's something else we will take on more of the responsibility to deconflict you from other traffic if you're a pilot in the airplane. And it's reasonable to think that going forward, we're going to have a similar environment where if it's instrument meteorological conditions, we're going to have other concepts of operations, other rules of the sky, other equipage requirements, just like we do in piloted aviation. So for us, it's about helping in that visual case, which is where, something like 90% of the unpiloted operations actually want to happen, and helping see and avoid other airplanes, because we kind of do actually see.
I mean, you alluded to this, John. I mean, you started off talking about your career with very large drones and how you at Insitu, you worked on maybe smaller commercial drones. And then in the context of detect and avoid, I think most people think about smaller drones and this non-cooperative traffic. But I think you alluded to it here, the fact that, urban air mobility, those hops you're talking about from Boston and Nantucket, I mean, Transcend Air is going to be doing that, right? If you're tracking what's happening in the eVTOL, STOL world, it's happening. So your detect and avoid, that can go on small and large drones. Is that accurate? Like I use the term drones very loosely. People get upset because I think there is a terminology problem in this. I'll say this industry, like it's one. But let's just assume right now when I talk about drones, I'm talking all sizes, and I'm including things like advanced air mobility and eVTOL aircraft in that, things that can be autonomously piloted and carrying people or cargo, or not. Can your technology go on all of those?
Yeah, and actually, it's just easier to say drone than unpiloted aircraft. It's just a lot of syllables, So yeah, I mean, we focused. The company got started laser focused on this size of drone, right around 30 to 50 pounds, that was capable of flying, decent distances, tens of miles, maybe 100 miles. And that forced us into a really tough design space because those are not large aircraft. In a typical 50-pound airplane, you might have 5 to 7 pounds of payload mass fraction available. So putting something on board that is a safety system is going to erode that payload mass fraction. So you got to be really efficient with your use of weight and size to be able to do that. And that's driven our current design. And just to give you and the viewers, some sense of scale, a camera for our Cassia system is roughly the size of an AirPods case. So it's a very small camera. And then the compute module is like 2 iPhones stacked on top of one another. So it's about 400 grams for our single camera system, which isn't a lot. But again, on a small aircraft, that's a business decision. So we focused on like the hardest space. And ironically, what that means is, every other airplane gets easier because there's more size, weight, and power available, right? So, and because we're an optical method, if we have more size and weight and power available, then we simply use larger lenses and larger cameras, and we give our algorithms more data. So for us, that initial focus on like the hardest part, ironically, has kind of made it easier for us to expand because we've solved the hard problem. And now everything else looks like kind of a subset of that problem because it's configuration change, not a core product change. So short answer is yeah. We're very focused on the future air taxi market. Matter of fact, even general aviation is in the roadmap because this is less about being the sole means of mitigation. It's about being a layer in multiple layers of mitigation against the risk of midair collision. So for us, in some cases, the small drones, yeah, we might be the only thing on board, but we sure hope you're doing some other things like figuring out what airspace you're flying in and having your flight plan designed to minimize the risk of potentially coming in contact with the non-cooperative general aviation aircraft. And then using UTM if you've got it, or using ADS-B in if you've got it. Anything you can use to be safe, you should use. And then our system goes on board as another layer. When you start to think about, well, even my personal opinion is that the first air taxis you're going to see are piloted, because then it's easier to get them into service because, it's just a different kind of aircraft, right? It's not a different type of operation, right? You don't jump right to autonomy. I do believe that we will get to that point. But in that process, a system like ours on board is just another tool that provides more data, more information to the operator, whether that's a pilot on board, whether that's a remote pilot, whether that's a system operator sitting on the loop. So, think of us as sole mitigation for small, additional mitigation for, the piloted environment. And then finally, I would say that we're a really valuable contingency system in that when the other layers fail, boy, it'd be really nice to have something that is going to help you avoid an NMAC, near midair collision, NMAC, every time. And that's one of the things our system does really, really well, because as the target gets closer, we get better resolution, we get better data to the autopilot that can then make a more informed avoidance maneuver and make sure that even if everything else fails, your airplane comes back. And so does the other airplane. And that ultimately is the safety baseline that we're shooting for.
Yeah, and certainly if people are on board, they all get to go home, right, to their
Yeah.
families. I mean, that's why I'm focusing on safety, and perhaps it's inherent what you've already said, but I'll ask it anyway. So why do drones need DAA then?
Why do drones need DAA? So all aircraft need DAA is probably the best way to say it. It's what's interesting and what you've seen in the community is that, let's take a Cessna 172, for example. When that aircraft gets certified, it doesn't have a DAA system on board. It's got a seat, and it's the human that gets inserted into that seat that provides the DAA after the fact. So every airplane needs it. And let me just walk the audience really quick. So say I was going to fly from my home airport here in Southern California called John Wayne, Santa Ana. I think they also call it Orange County. So it's like put as many syllables as you can in front of an airport. Let's just say KSNA.
There you go.
And you want to fly to Van Nuys, right? So that is through some of the most complex airspace that you have in the world, frankly, and some of the busiest airspace in the world. But yet, average pilots, private pilots with a couple hundred hours make that trip safely every day. How do they do it? Well, they plan the flight, they use the airspace, they use the equipment, they use ATC, and then they look out the window. So it's all those layers that get put together. Any unpiloted system needs to be able to capitalize on all those layers as well. And the one layer that we removed with the unpiloted world is the pilot in the seat, the human eye-brain combination, i.e. the last line of defense. Just like Part 91-113 says, the pilot shall see and avoid all other air traffic. There's not a separation standard in that rule, right? It doesn't say 500 feet, 2,000 feet, 2 miles. There's other places where, whether your VFR, your cloud clearance and your aircraft distance, are specified. But in 91-113, it just says don't crash, right? Just stay away from other airplanes. So we got to satisfy that as a minimum, right? And that's really where IRIS is focused, is trying to give an analog to that last line of defense so that we can start to take more incremental steps towards full integration of unpiloted systems with piloted systems in the national airspace.
So you mentioned that IRIS is an optical solution. Can you explain, or you provide an optical solution? I didn't want to misspeak there. And I believe your product, your latest version, is called Cassia 360. Can you walk us through how exactly that works to do exactly what you just said?
So our first system, which we currently call LR, although we might be going through a bit of a renaming exercise, because why not? It's fun to rename things. Cassia LR is a single unit system, and it's got about an 80-degree field of view, and it was designed to be used just straight out the nose of an aircraft to basically clear your right of way during your flight plan, or during your flight of your mission. It's very effective. As a matter of fact, I saw a customer demonstration down here in San Diego County a couple of weeks ago. One of our customers is called Sensi's, fantastic customer, great operation. And they were down doing some demonstration for some, first responders, for some energy service providers, and they launched their airplane. There was no, fanfare or anything. It was just a normal drone launch, just like you'd see anybody go through a normal checklist, clear the airspace, check the weather, brief everybody. Okay, let's go fly. And as they were flying their mission, this one happened to be a kind of a mapping mission with a lawnmower pattern. Every once in a while, you'd hear the operator, chirp, up, detection. And we're like, oh, that's weird. And you look up in the sky, and sure enough, about half mile away or so, maybe a mile away, you'd see a general aviation airplane coming, and you'd see the drone deviate, and then they would get farther away from each other, and the drone would return to normal. And it was It was climactic in the fact that it was completely anticlimactic. Like it just did what it was supposed to do. So, so that's the single camera system. And that's basically when it's working, you don't even know it's working unless the operator was chirping out detections. It would have just gone and done its thing. When it comes to the 360 that you just asked, one of the things we learned from working with the FAA and the IPP program is that because of this basis of see and avoid being based on see and be seen, there wasn't a reasonable path to say that the human pilot was going to be able to see the drone executing the mission. So that means the drone has to be more aware of more of the airspace, including the overtake from behind. There's plenty of contention in the standards community today in, you know, the discussion between industry and regulator around whether that's really necessary or not. But hey, let's be safe first, and then we'll figure out how to optimize. So we went and built a 360-degree view system, which is, you know, best way to think of it is just take the single camera system and just add more cameras to it. It's a bit more complicated than that, as my head of engineering would attest. But once you do that, now you can get these detections in every angle around the aircraft and then affect your avoidance maneuver. For us, it's the same software. It's just a different configuration of cameras based on the use case, the concept of operation, the regulatory environment that you're in. We fully expect that even in the USA, you'll have a range of configurations that'll be acceptable for commercial use, depending on where you're flying, what you're doing, who else is flying around you, and what really the risk profile is of the mission. So you might have anywhere from 1 to, you know, maybe it's 15 cameras on an air taxi, right? Based on the configuration and being able to see the sky, who knows? But, you know, our drive is to make the hardware as, you know, almost, I was going to say the word disposable, but we don't want you to throw your cameras away. As inexpensive as possible, right? Because it's not about the hardware for us. It is about the software. And all the hardware really does is give imagery to our computational methods, and then we go do what we do.
Well, perfect segue into a question we got from the audience. We got Scott Schofman, one of our regulars here. Hey, Scott, coming at us live from Texas. And Scott's one of my Patreon, a part of my Patreon community. So, and he's also going to be speaking at Interdrone, as is John. So we'll talk a little bit about that at the end here. But Scott asked this: should we have brighter line minimum standards around avoidance at the regulatory level? I think you alluded to this earlier, John, where right now it's just, hey, don't crash, basically. You know, not the 2 mile or the, you know, X number of feet or whatever. What do you think about that?
Yeah, this is a fantastic question, right? And I'll start by parsing the acronym DAA, in that, you know, colloquially we refer to it as detect and avoid, and the and is the middle A. Well, we actually at Iris, we call it detect, alert, avoid, because when you start to take and separate detection from avoidance, well, there's got to be something in the middle that then takes whatever sensor modality you're using to detect and alert some other system that's a decision-making system, whether that's a human, whether that's an autopilot. So we tend to stick alert in the middle. And, you know, the question around avoidance and, you know, brighter line minimum standards, I think is a really good one. And it's one that I'll start answering by saying, if you look at the piloted community today, you know, the generally accepted standard for safety, there is absolutely no stipulation other than right-of-way rules for the human pilot to avoid a collision. And, you know, I'm a flight instructor, so I spent a lot of time in the right seat with students. And I can tell you one thing: the human is the most non-deterministic system in the air. Like, you just don't know what someone is going to do when presented with a stressful situation. Some people fight, some people flight, some people freeze. So, you know, I think this is an interesting one. We at Iris, we tend to not dive into the avoidance part too deeply because of this very question, in that we're not an autopilot company. We're a sensor company, right? We detect and we alert, but the avoidance is largely going to become increasingly, in my personal opinion, the domain of the operator. Because at the end of the day, it's the operator's brand that is on the approval to go operate. and they're the ones that are carrying a large chunk of the liability for the safe operation of that operation. So I think that avoidance, yes, I do believe that standards are coming. ACAS SXU, as an example, is a great exploration of existing known kind of TCAS based approaches to providing collision avoidance. And that community is strong and making strides. So I would say yes, brighter line. I don't think it's black and white, right? Because depending on where you're operating, you might not need to do much, So, okay, let's not over stipulate a standard that then restricts operations. Let's be, more performance based and use case based around this. So that's a fantastic question. I appreciate that.
Yeah, being a lawyer and having been in the Air Force for as long as I was, 28 years combined service, civilian and military, we always say flexibility is the key to air power. And I really do, look, I'm all about policies and regulations, but at the same time, I don't like boxing operators in. And that was always my goal as an attorney, is to find a way to get to yes. Let's give them some flexibility, because to give the lawyer answer, right? Like you said, John, it depends. Aircraft are going to be flying at different speeds, different altitudes, different situations. And to create bright line rules could actually be more dangerous than giving people that flexibility to adjust as needed. But having that reasonable buffer, whatever that reasonable buffer is, and maybe it's not even a number. Even in the law, we use that term all the time, reasonable. Yeah, right. Because for a reason, you don't create a bright line rule. There's a lot of chat right now about the Fourth Amendment and some case, and drones, and, this idea of what is a reasonable expectation of privacy. Well, it's not really defined, very specifically for a reason, because it's going to change over time. And I think that is the case here too. Now, John, you mentioned this demo that you just participated in, and that your tech is out there being used. What are some of your success stories that you'd like to share with us?
Yeah, so I just mentioned our, Senseis is one of our great US customers. We have an Australian customer called Swoop, who is doing very similar things, and they have a really novel business approach to doing this. But those are some of our newer entrants, some of the small drone new entrants to the space. But we're working with some of the largest brands in the space as well. Matter of fact, Verizon is one of our investors. So, it runs the gamut. The use cases for drone aviation. I've said this, I spent 2 years at Boeing too. I don't know if I said that in my intro, in their future mobility division called Boeing NeXT. And one of the things we did is analyzed all of the different use cases for aviation, specifically that would affect Boeing roadmap in the future. But one of the things that kind of came out of that analysis is that, the advent of drones hasn't created new use cases. The use cases have been there for a while. And most of them have been flown by piloted aircraft. So the advent of drones is not about creating new jobs. It's about doing the existing jobs better and more efficiently. And I personally believe, Don, I believe that the advent of autonomous aviation, starting at the small level and then ultimately getting up to, say, the 777 level, is going to make aviation safer. And the reason I say that, and it might sound weird as a guy who spends a lot of time flying small airplanes for fun, if you pull a null report, which is basically a meta-analysis of all the NTSB findings every year, the null report very clearly shows that general aviation fatalities, 80% of them, 80% are caused by pilot error. So clearly, if we get humans' hands off of the controls, we're going to be safer in the air. And I hate that because, I love flying, but I love that because I love flying. So I think this is the right path. I think the advent of drones and the introduction of drones into these use cases is a great way to incrementally learn how to improve the safety of the system overall through the introduction of these small aircraft. So that's kind of really goes to my passion for leaving Boeing, frankly, and coming over to Iris, is bringing and bridging the legacy aerospace world with this fascinating new world that has been really well capitalized over the last few years from the venture capital and the private equity communities, and trying to build this bridge so that we can start to really have greater enjoyment and benefit from aviation writ large, at cost points that are affordable and allow a wider distribution of these capabilities.
Yeah, and like you said, John, I think the use cases are only as limited as our imagination. I'm on Clubhouse, and Catherine Ball from Australia was telling us how for years they've been using drones. Lifeguards fly them out, drop the life jackets or life rafts, actually track the individual, so the lifeguards then go out in a boat and they can have in real time where exactly the person is. And wow, just amazing application and an interesting use case. They're also using it to spot sharks. My friend Jackie Jumachik out there, Hover UAV in Australia, is doing that. So, just again, so many interesting things we can do. By the way, great comments in the chat. Scott, thank you for your well-reasoned answer there, John. And we have Derek Lyons on Twitter saying, thanks for the great chat this morning. Every time I hear John, I learn something. So do I. So I agree with you there, Derek. So awesome. We only have a couple minutes left, and I want to give a shout out to you, John, and to Iris for your support of the Women to Watch Global Awards program this year. I know we're going to talk a little bit about your goals for the year, but for those that don't know, I did put on social media this morning. Iris is our spotlight company this week because they're sponsoring the Iris Entrepreneurship Award, which is one of 4 individual awards for the Women to Watch awards program this year. Makes a lot of sense because you all really epitomize entrepreneurship, and I love that you're paying that forward and hoping to bring forward some great women for that award. So everybody nominate. All that stuff's on the Women in Drones webpage, and thank you guys for doing that. So with the couple minutes we have left here, John, if you want to tell us about your goals for Iris, maybe this year going forward, and then anything else as we wrap it up, just a couple minutes left.
Yeah, I think this year, one of our highest focuses is, or foci, if you want to use that term, although those of us that have tried to run a defense business in the US that had foreign ownership knows foci is a much more difficult thing and different, but it is the Beyond program with the FAA. It is about regulator engagement. And if that's, one thing that I like to say that I kind of brought to Iris when I came over from Boeing is that you really have to collaborate with regulators, especially when you start talking about new capabilities, because it's not the regulator's job to go invent. It's not their job to ideate what the rules should be. It's their job to regulate. So they need industry to bring things in front of them, not black boxes that you just say, look, it works, give me an approval. Right? They need to be part of your journey. They need to see how you're thinking about the problem. They need to see how you're solving the problem so they can understand all of the success and failure modes of whatever system you're bringing to the table, whether that's a whole airplane or a component technology. So I think, we've shifted our internal culture to that kind of transparency with global regulators. We recently had a really big win in Canada with Transport Canada and this partnership that we have to allow people to come learn how to do BV loss on the Canadian ranges. And that's just great. That's going to help people learn and come up that curve with safety first in mind. With the FAA, we're deeply involved in the Beyond program in a number of the different sites, but the primary site for us is Reno. That's where we basically have our base of operations and we do all of our flight testing. So we're the main industry partner for the city of Reno for this use case of river rescue, which is where every summer there's a rainstorm somewhere else that no one's really paying attention to, but because of the topology and the nature of the surface, turns into a flash flood really quickly. So people get swept downstream every year and you don't know where they are. So first you got to find them, which is kind of like a search and rescue mission. And then you got to be able to keep eyes on them so that first responders can accurately position themselves ahead of the flood to go get the people. So it's a really interesting and valuable public benefit use case. And it's one that I think pushes all of the right angles of a beyond visual line of sight use case for small drones, because you don't know where you're going to go every time you're going to fly. You need to cover a large area basically autonomously, and then you need to somehow maintain station and refer positions to other people and other systems. So really looking forward to it. We're on a plan right now with the FAA and deeply engaged, and that's our primary goals this year, is to make sure that we continue this collaboration We provide the regulator the corpus of data that they need to see what part of the safety stack the CASIA system fits into, so that then we can start getting it out to more people so they can increase their level of safety on board their systems.
Well, that's a perfect goal, actually, and I love what the FAA is doing in the Beyond program, and so many companies like yours, John, that, like you said, are informing the regulators and helping move us forward. You know, I do have my wish for this year. I don't know that it'll happen. I would love to see at least a draft Beyond Visual Line of Sight rule, you know, from the FAA. If not, maybe early 2022. But I know the work that you guys are doing at IRIS will inform whatever that looks like. All right, we got to wrap it up here, but just a couple quick announcements. Number one, Desi Eckstein is watching, and she is our Coffee Connect person for Women in Drones, and she says we're looking forward to having John on the Coffee Connect when on the May 5th. So dial into that, and if you're not a Women in Drones member, you should be. And as I mentioned before, John will be on a BVLOS panel for Interdrone. If you haven't bought your tickets yet, buy them. It's going to be the first live event. I guarantee it. Well, I can't guarantee anything in this environment, but I have a very strong feeling it's going to happen. And it's going to be in Dallas, Texas at the Hyatt Regency from 10 to 12 August. And I would love to meet all of you, especially the ones that are dialing in every week, so I can meet you in person. And dial in next week as well. We have, we're kind of switching back a little bit to security, where we've got Tim Haney, the CEO of Spectrobotics. That's a local Colorado company. They're doing all kinds of amazing analytics, including with swarms, drone swarms. And Gary Korn is a retired Army colonel. He's got a lot of things going on. He's a law professor. And he used to be the head lawyer at Cyber Command. So we're going to be talking a little bit about cyber law as well, because at the end of the day, drones are cyber entities and raise a lot of issues, especially when you're talking about security and swarms and some of the things that Tim's doing. So that should be a lot of fun. So the first time we're having two people on it at once, other than our special guest with a special podcast with Jonathan Ruprecht and Brendan from Race Day Quads the other day. It was kind of random. All right, that's it. That's all we got for now. Thank you so much, everybody. Appreciate the props, appreciate the comments. Have a great week, and hopefully we will see you next week. Join me on Patreon. See some bonus podcast footage with John and all of our other guests, and my 2 times weekly blog, Deliberations by Dawn. I talk about national security, commercial drones, and leadership. So anyway, great to see y'all. Hey, Mike D, Mike D Casola out there. Good to see y'all. All right, take care. Have a great week.